Well, we are in the soil macromorphology studies. So after a prolonged after texture in the previous lecture, today we are going to discuss about the structure. Students, so structure, everybody knows what is the structure. It is nothing but an aggregation of individual soil particles into a large units. Please remember this word. In a large units with a plane of weakness between them. So there will be some sort of weakness will be there. That means very weakness means just if based on the rupture it will easily rupture. So individual aggregates, so these small aggregates are called what is not this is called pets. Pets are nothing but it's a natural aggregate. So generally these are the soil particles. So commonly all these particles will combine and form a pets. So these pets will form a pet sac around each other column structure. So it will form some unit structure. So this is regarding soil structure, students. And coming to the students, now, most of the horizons do not have any aggregates with naturally preserved boundaries or considered as so. Whatever the horizons or whatever the layers, what which if you see any layers, there is no aggregates or nothing or any pets. Those condition is called structureless. It is a very structureless students. Mostly students in structureless, there are two conditions are there on a single grain. Please remember based on these two concepts, further lectures will be built up. So single grain means it's nothing but in name itself it says it's a soil material without any cohesive and individual where there is no any cohesive force are paired or fall apart from the profile. So there is no any bonding, so easily it will be fall down that grains. Massive means we can see material is a cohesive and fails to show any natural occurrence plane of weakness when the pried from the profile. Pried means just while we are using the kurfi, while we do any mechanical disturbance, it will fail. It will, so it will the weak it will show some weakness of attachment. So it will be fall down. It will that massive structure will be falls down from the horizon. So these are the single grain and massive grain. So massive grain structureless conditions which we usually seen in horizon or profile description. So these are the types of soil structure, students. So as I said, this is the SRF class, so there is no need to go details around this. So granular, blocky, prismy, bracken block, subangular blocky, angular blocky. The two types are the prismatic, columnar, and platy structure. The single grain structures. So these are the single grain structures. So like this, we will see different types of structures. Yeah, this one I have to say. See, in blocky also subangular blocky, angular blocky, platy. If you say in platy also, if you see this type of structures is called lenticellular and is a platy, prismatic and columnar. Two types are there. If the edges are very round, it's called columnar. If it's a flat edges is there, you can see prismatic and wedges. If you see this type of structure is called wedges. Single grain is the loose materials of the rock. Mass means this is what students unconsolidated mass. Once we disturb with a kurfi, kurfi means while we are examining the profile, we use one tool that is called the kurfi. So once we disturb this, we can see a massive fall down of this type of structure. So these are called the structureless types. These are the examples of the structure types. Okay, students, remember these things and note down all these things. So structure is and which structure is suitable for the agriculture? Can anyone answer?
Crombie, sir.
Crumby, yeah, crumby, not a single grain. It's a crumby structure, is very suitable for the agriculture purpose. So these are another lively picture, students. These are granular, these are blocky, these are yeah, these students. This is what my intention to say. These are the massive structure, you can say. These are the massive structure, and these are the single grain. This is a single grain structure, and this is a platy structure. So this is a natural way. This is the original photograph. It's a natural photo, not a diagram or anything. This is a natural photograph. And students, based on the size of the pet, students, so pies depend upon the size of the pets. By using the what is the size of the pets, we have identified the 6 categories of the pet types in class of soil structure. What are these? Everything. So very if you find if you very fine, if you want to put any pet in very fine soil, if it is in case a granular or platy, it should be that size should be around 1 mm, be less than 1 mm. That pet will comes under the 1 mm. It's a very fine class. In prismatic and columnar wedge condition is prevailing that particular, those pets are 10 mm. So in blocky, it is less than 5. All are in mm only, students, units. If it comes under the fine conditions, 1 to 2, here it is 10 to 20, it is 5 to 10. And medium, it's 2 to 5, 20 to 50, 10 to 20, and coarse is 5 to 10. All are millimeters, 5 to 10, and 20 to 50. These are the conditions. This is the granular platy structure conditions, the prismatic columnar, and wedge conditions are like this, and blocky conditions are like this. And coming to the very coarse is more or less 10 millimeters. It is 100 to 500. It is a more or less 50. Is a condition, blocky conditions. In extremely coarse conditions we can't find any structures in granular and blocky. But we can say prismatic and columnar wedge condition. That is more or less 500 millimeters. So this is the condition, students, based on the shape of the structure, based on the size of the ped. So this is the classification. If the peds are aggregate by the granular plate structure, you can found, and the size is around more than one. So this that comes under the very fine. So please note down please note down, make a note about this table. It's somewhat very important. This is what usually you have found very new condition, depend upon the pet size, etc. Have you noted down, students? I hope you are doing so. Anyhow, coming to the next, students, grade. So based on the grade also, grades are identify how well the pets are and what is the how easily the structure observed in the place of the parent. So naturally, these pets, we have given some grades. Their grade is given. So we classify based on the grade these pets are. So grade is completely depend upon moisture conditions. And also we need a lot of experience, students, to find out the grade or to evaluate any conditions in either an extremely wet condition or extremely dry conditions, where any type of conditions we need some sort of experience. So the soil scientist or a particular person should have a proper experience. So based on the grade structure, depending upon the grade, we have divided three types. One is called a weak, moderate, and strong grade of the structure. One is weak grade of structure, moderate grade of structure, strong grade of structure. What are those? So weak grade of structure, students. Structure units are barely observed. This type of weak grades you can observe very rarely. You can observe when you rub it. What happened? The soil materials parts into mixture of the whole are broken. So once you just rub with your hand, what will happen? Everything will be broken down. All parts will be drop it down. It will be more. So most of them will exhibit no structure surface. So mostly this type of grade conditions, what you can see, there will be no structures. There will not be any structures in a weak conditions. But if you see the moderate conditions, students, here you can see some well-formed evidence of undisturbed soils. So you can see some disturb when you rub the soil material. Here also you can see some sort of mixtures will be gone into a whole units. So here also you whole units, but here you can see it will, once you rub any ped, what will happen? Some lumps and lumps, so some units and units will be fall apart. But here you can see whole broken units. Here you can see only broken units, but here you can see whole units. Units means, see, students, I want to say in a diagrammatic way. Students, say for example, this is a big ped. Once you rub with your hand, what will happen? In case of weak conditions, what will happen? All the units will be fall apart like this. Small parts, all the units will be broken parts will be. But in condition, if a moderate condition, if you see, what will happen? Some lumps and lumps units will be fall down if you rub with your hand. Particle size will be more. So that is called the moderate conditions. And you can see mostly we can see undisturbed evidence also. You can see. And coming to the strong conditions, students, these separates are clearly when rubbed in the soils. When removed, the soil made separates wholly into a unit. So if you take any unit, some big units will be fall apart and compared to this. So the structure was very strong. So these are the grade, students. But to identify these conditions, these grades, we have that particular soil scientists need a lot of experience. We need a lot of experience regarding this. So these are the grades. What are those grades? Weak grade, moderate, and strong. Just remember, and then also students, aggregate surface are proper distinct from those are fractured structures. So in strong conditions, we can easily see the proper evidence of aggregates. So the properties, the pet properties will be different from the other properties when compared. That is in case of strong. And weak, easily you can identify. Moderate, just I said here also you can see some aggregates will be surface will, but here also you can see some distinct properties from the fracture surface. In both the cases will be there, but the grades are somewhat very low. It's a moderate grade one, but here it is a very strong grade. This is regarding the grade of the soil structure. And coming to the consistency, students, it is completely this consistency. It is nothing but some evaluation of cohesion adhesive properties. This is what I asked. So the response of the soil material to the applied force, how far the response will be there. So field evidence, field evaluation of soil consistency includes what are the three consistency usually we will see in a field condition. That means if you go to any profile description, what are the consistency you can observe in the field itself? What are those called? The rupture resistance or shear resistance. Mostly geotechnical engineers usually see these conditions very seriously. And coming to the stickiness and plasticity of hand specimen. Hand specimen is nothing but the structure we made. So most of us, how many of you have gone to beach? So if you go to the beach, what we will do? We will construct some different castle. Castle means kotai, the fort. We will build some forts. We will be in childhood. हम बचपन से क्या बनेगा in beaches. What we will do, we will construct some with sand we will play. So generally what we will do, so suppose this is a beach, you think this is a beach full of sandy. What we will do, we will construct some, with the help of sand we will construct some constructions. See, so say sometimes we will construct some houses, all those things. It will be hold, students, it will be hold. Why it will be hold, it was holded? Can anyone say? We have constructed in beach, we have constructed some constructions with the we play with sand generally. So we will construct many things. Sometimes we may construct some temple, or sometimes we can go, we will construct some different constructions. Why, how it was holded? Can anybody have idea?
Presence of moisture,
Moisture,
cohesion.
presence of moisture. So presence of moisture is like that. Okay, if I add, so the beach is here, suddenly what will happen? The waves of sea water came and hit this. What will happen? So the water waves came and hit this construction. Our castle means our we are playing with the sand. So the structure was hit with the water. What will happen to this condition, to this castle? Castle means fort, fort. It is another. So what will happen to this condition, students? It will be hold. It will be very strong.
No, sir, it's breakdown.
It will be collapse. It will be collapse, right? All these castles will be she will be wound up, and all the sand particles will be distributed evenly in the land itself. So this is a condition. So based on the small principles, students, and do you know why this? You said one condition, due to the moisture, sir. That is why this construction, or this temple or this castle was holding. Do you know why? Do you know why that? When there is enough moisture, when two particles, students, here you can see one physics concept will be applied here, that is called the surface tension. When two particles, or when two sand particles were attached like this, so there will be some force will be there, some cohesion will be there, adhesion. Yeah, of course, sorry, cohesion is, yeah, what is it? Like particles attraction is called as cohesion,
Co-
right? Cohesion or adhesion?
cohesion, sir.
Yeah, cohesion. So when two particles were are attached, so due to the surface tension, and also you can observe the water, no, some water will be present in between here, in water will be, so what will happen, some force between will be held by this water. So the small water will be hold these conditions, and also there will be some force of cohesion, surface tension. Due to the surface tension, these particles will be hold when there is a enough moisture. So that is why your castle or your construction in the beach, what you played, all those things will be hold properly. But when the moisture condition was too high, what will happen? The surface tension will be reduced, the particles will be move apart because more water is there and comes. That's why your entire construction is collapsed, and all the sand was completely gone off. So this is based on the small principle, based on this thing, that our dams, most of our constructions of buildings, everything was completely designed by only this rupture resistance only. So today we are going to see about the rupture resistance and all those things. I hope you are understanding. And another one is called stickiness. Stickiness is nothing but, after when agriculture field, when we rotate any farm tractor, or when we work with agriculture implements, some sort of stickiness, if it is a very clay conditions, especially in vertisols, you can see this condition. Some stickiness is there. Based on the stickiness and the plasticity in hand specimen. Plasticity means generally in BSc first year, I think, you usually one experiment is there by molding. No, if the sand, you will add some amount of water, you will make by taking 1 or 2 grams of soil, you will add some water by hand, and you will press it. You will press it, and you will see if it is was holding. You will say this is a somewhat lower plastic limit. And if that molding was not unable to hold me, that is called the upper plastic limit. So based on this upper plastic, lower plastic limit, we will go with the plasticity index. That is called Atterberg's limit. All those things. But today I'm not going to teach you Atterberg's limit. So this is a SRF class. So that's why we will see indeed something different in the plasticity limit. So rupture resistance or shear resistance, we will see. And all these property students are completely critical to the assessment of the soil water only. So soil water condition, based on soil water dependence on all these conditions were prevailed. This is the consistency. Now we will see the rupture resistance. What is the rupture resistance? Is the evaluation of strength of soil to withstand an applied stress. So rupture resistance is nothing but how much the soil is withstanding to the stress we are giving. So we are giving some stress to the soil, and how far the soil was giving some resistance. So generally, how we will evaluate this rupture resistance or shear resistance? Generally, what we will do to evaluate this, we will take a block of soil sample, say around we'll do, and we will make 2.5 to 3 centimeters on edges, removed from the edges. Generally, approximately 2 to 5 centimeters of soil sample we will take in from the edges of the horizon, students. Sometimes it may be crust or plates around 1 to, if it is crust or plate, we can say it should be around 1 to 1.5 centimeters. So around, we will take some block of soil sample from the horizon. Okay, students, what will happen? We will estimate the moisture content. We will estimate the moisture content of that particular block of soil sample, and the following operations to rupture the specimen for the perform until evaluating. So we will do some rupture resistant experiments. So what we will do just now, what I said, we just now in castle we will make some mold, and based on that mold, how much it was resistant, we will add some more water, means that resistance will be fall up. So based on that, experiment will be conducted here. And and also, if there is any cementation, the cementation requirement, if the cementation means that holding is of the specimen is air, if you want to find any cementation is required, means what we have to do, the specimen should be air dried and then submerged in the water for at least 1 hour, and air dried samples do not slake. So when this air dried samples, it is for actually, if you are in laboratory, I can show this very well. The general students, if you want to find any cementation require, test any cementation requirement, we will put, and we will put this full of water. What will happen? And we will put our specimen. Specimen means, so we will put some air dried specimen and see that, student, this should not be fall apart. Fall apart means it won't be slake. That means slaking means it should not be fall apart. It should be very stable. It should be very stable. This particle should be, this pet should be very stable, to find out that. So the based on this experiment, we will, after estimating the water content, and by performing some experiments, just as I said, we will construct some structure, and we'll add some water to it, how much water it was resistant. So based on all those things, we will come to a conclusion, and we will classify that how long the rupture resistance was present. So based on that, student, these are some classes in the dry condition, how the moisture condition, or cementing conditions. So anyhow, students, I will say one raw material. I hope you are not understanding. See, students, say for example, you take 3 plates. Okay, you take 3 plates. Okay, students, in one plate, what I did, I'll pour some sand, individual sand particles, zero moisture, there is no water. What will happen? What will happen? I'll pour sand particles. देखो, मेरे पास थ्री प्लेट है, एक ही प्लेट में सिर्फ सैंड पार्टिकल ड्रॉप किया, ओनली सैंड पार्टिकल्स आई हैव यूज्ड इन वन प्लेट. How the particles will be distributed in the plate? What will happen? Please answer. In one plate, I put only sand, no moisture is there. What will happen?
Distribute in all directions.
So it will fall apart. There will be nothing will be there. Sand will be here and there in the plate. Here and there in the plate. But at the same time, the next here in this plate, I will add some moisture, some limited moisture is there. It was holding that structure. It was holding that structure. Right? It was holding. Right? It will be hold or not?
Yes, sir.
It will be hold. In the next plate, what should I will do? I will take the same thing, but with somewhat little moisture. Then what I will do? I have same moisture, but I will add some amount of water to it. In this plate, I will add some water. What will happen? Here I won't add upon the structure, but I will add on the side. What will happen? It will be stay stable. It will be stay stable.
No, sir.
Why? Why? What happened? Just now I said, what will happen? So due to the more moisture, what will happen? It will be collapse. So all this part, all this so-called structure will be collapsed here and there, just like this. Just like this part, it will be collapse. Generally, this type of small experiment usually do in the beaches. So in the beach, where we will do such things are both. This is a sea, the complete sea, and this is a shore. So naturally, up to hardly here you can see some moisture. But if you go too far, you can see some dry conditions in there. So here you can't construct any, nothing you can construct. You can't play with this sand, but you can play with this sand. Here you can play some extent, but you can't play here. Why? Because the water will come and hit this, and it all the particles will be move out. The same thing is done in this rupture resistance also. The same thing was happening in rupture resistant accident also. Based on this small experiment, we have get this one classes. Dry conditions, the first plate, moist, second place, and cementation means that generally students, the holding cementations, the specimen means the structure what we have made. So if the condition in dry condition, it will be loose. Moisture condition also, if the same loose sample was used, it will lose. Cementation, as it was loose, there is no, it is not applicable. So here there is no specimen, no construction was found here. At the same time, in a soft condition, if you take any soft sample, what will happen? The condition in dry is somewhat soft. Here it will be somewhat very friable, even though you can't found any cementation. Cementation means you can't found any proper attachment. Here also you can't find. So whenever you slide this sample with between your finger and very slight thumb, you need very slight pressure you need to remove this to remove that structure between a thumb and forefinger. But you can see in dry, if the condition was dry condition of that particular specimen is dry condition, it will be very slight. The condition is very friable. Here also it will be some friable. Cementation will be there, students. Here the very weak cement, just like your beach construction, it will be very weak. You need here also you need to slide the thumb between the. We need some little force to remove that particular weak sample. And coming to here is moderately hard. If it is a dry condition of your sample is under dry condition, it is a moderately hard. It will be very hard. If you moist that moderately hard, it will be very firm. It will be somewhat very weakly cemented. Here the cementation has started. You need very weakly cemented. If you want to break that particular, if you want to remove that specimen, you need very moderate pressure. So you need put some more energy to remove that pressure. And coming to here, it is hard condition. In dry condition, it is very hard. It is very hard. Dry. If you take any dry sample, it is very hard. If it's moisture, it will become very firm. Here you can see some cementing was taking place. It was weakly cementing taking place. And if you need a strong force, you should slide your thumb and forefinger with we have to give very strong sliding should be given. Then only you can break this specimen. But if the condition was very hard in dry, in moisture condition it is very extremely hard. If you wet the condition, it become very extremely firm. And in cementation, it will be moderately cemented. It will be moderately cemented. Not that when compared to this, it was somewhat moderately. You need two hands. So you needed two hands to break that particular to rupture that block. So you have to use your two hands. Then only you can break that particular specimen, that particular structure. And it is extremely hard. And if you add the moisture to that, it will be slightly rigid, and finally it will become very strongly cemented. What you have to do? Then you have to use your foot. So you should use your legs. So you should use your legs. Then only you can break that particular structure. And if the condition was too rigid in dry condition, and if that was moisture was added, it will also become very rigid, and cementation will be very strong. So what you have to use? You have to use hammer. So you should use your hammer of 1 kg hammer. Then only you can break that particular specimen. And it was too rigid, it was very rigid. Dry condition also very rigid. So what will happen? Enduring. So it was endured. So here you cannot rupture with the hammer. So you need a very strong, you have to beat more beatings, you have to give to that particular structure. Then only it will be, it cannot be rubbed with the hammer conditions. So these are the, I hope by reading this, you can understand what is my intention to say about the rupture resistance. Rupture resistance means stand how strong it was hold for the given pressure by us or by the natural condition. These are completely depend upon the moisture condition and cementing conditions between the particles. So all these things. So these are the different classes, students. Please note down. This is very important for your examination purpose because this is a new syllabus. Up to now, I didn't see any questions from here because it's a new syllabus. It was newly added. That's why. So please cooperate and try to understand. Coming to next is called stickiness, students. Is nothing but stickiness. Generally, in our childhood, we usually play with clay. We usually make some different shapes. Like sometimes we'll make telephones, sometimes we make some small dolls. All those things we usually make with the clay conditions. So generally, students, it is a tendency of wet material to adhere to the other objects. This is what the stickiness. The word itself is this. So how much tendency to wet condition was adhere to the object. So generally, it is evaluated by the wetting of handful of soil. How the experiment will be conducted: handful of soil with a continuous squeezing and mixing with the alternatively adding water. So and drying the soil to determine the when the greatest degree of stickiness is achieved. Generally, what we will do: we will take some handful of soil, we will add some water in our hand, then we started mixing with our hand. So we will wait until how long it will go into stickiness. The sticky nature is taking place. Generally, students, we can compare this for your blind experiment. So I hope while you're preparing any flour, while you're mixing with any flour like chapati or something, usually we add some water, while mixing that flour, the chapati flour. So what we at very first 1 or 2 drops, you won't get the stickiness of that flour, of that powder of that flour. So if we going on adding this, what will happen? At some case we can see that flour was attaching to our fingers. That is called stickiness. Same thing was happening, we are conducting here also. We'll take handful of soil, we'll add some water, then we will mix with our hands, then we will see how long it was sticking to our fingers. That is called stickiness. So at the point that the sample of material be adhere, when the point was achieved, when it was when the place was between, when there was adhering was started between thumb and forefingers and squeezed and released. So you can see the point of the material is placed between thumb and it is squeezed and released. You can see some stickiness feeling, you can see when that point was achieved. The stickiness class is determined according to the following observations. So there also in stickiness also we have some sort of observations. How the material was reacted between our thumb and forefinger. So how that material was sticked between our fingers and forefingers. So based on that, we have one classification. That's based on this, that thing also we have gone to the stickiness, how the stickiness was taking place. Now we'll see students, non-sticky students. Non-sticky means how much we add materials. Mostly this you can see in sandy conditions only. Almost no material was adhered to the thumb and forefinger. There is no attachment. On our fingers there will be no material will be adheres. That means no attachment will be there between our thumb and forefinger. It is called the non-sticky. Slightly sticky means students something, not a much, some sort was adhered. Soil stretches little, so you can say some stretching will be there, some wears will be there. Moderately sticking means something somewhat extra. Soil was adhered to both the fingers. Stretches means it will while we are removing a forefinger, it will give some sticking feel in that will give here in moderate conditions. Very sticky means our both fingers will attach very firmly, very strongly. You can see this that sticky nature of that particular soil. This is called the stickiness classes, students. Generally non-sticky, sticky, moderately sticky, and very sticky. Generally, while we are reading about Atterberg's limit, we most of for BSc students or MSc students, even for PhD students, up to now, we are not going to teach this type of things, students. But it was newly added to you, so try to make a note all these things. So non-sticky, slightly sticky, moderately sticky, and very sticky. This is the test description. So based on the thumbnail. So plasticity, students. So everyone knows what is a plasticity, right? Plasticity is nothing but is a soil material ability to deform without rupturing. It is nothing but here also students. That this is one experiment, students. Generally, we will take some soil to evaluate the plasticity. What we will do for molding a handful of soil, which particles of range of more than 2 mm. Generally, it will mixture of both sand, silt, and clay. And what we will do, we will give alternate wetting and we will give some wetting and added some dry soil to it. So we'll add some water, at the same time we'll add some soil also. Then what we will do? we'll make a roll or we'll make a wire like this, like this. We'll make on a plate. Generally, it's the glass plate, student. Generally, on glass, we usually do all these things. The glass plate and glass plate. What we'll do? We'll make a wire or a roll like this. Mostly, it will be around 4 centimeters, students. And while we are making this should be held by its own weight. That means it should not be any brittling should not be taken place. So that is called the plasticity. That is called the plasticity limit. So how long it was holding, how much length the soil was holding. So whether it was holding up to 4 meters or 8 meters or 10 meters or even 100 meters, whatever might be. So how long it was holding based on this wire holding. See, this is what I mentioned here. Along it's 4 centimeters long that cannot support that can support its own weight when held on the end of the rolling. So when we held these ends of the roll, when we pick up this end of the roll, what will happen? The material between the hands, how long it was holding its own weight. Just I want to say this. Yeah, this is what, students. So this is the glass plate. This is the threads. Generally, we'll make small soil balls. Then we will rub this on the glass plate. See, this is my experiment. So here you can see some sort of wire is there, but here you can see some broken wire is there, some broken conditions is there. Either the length is there. So based on this, the cylindrical rolling process, we usually say this is based on wire. So how long it was holding? This is one experiment. So the results of outcome of the record. So what is the condition, students? What is the condition? How long, how much length was holding by this roll? You see here, you can see some this structure is unable to hold because lack of some plasticity. It was completely broken down. So based on how much length was holding by this particular soil, there is a classification that's called the plasticity class. Very first one, students, non-plastic. A roll of 6 mm thick cannot be formed. Here you can see you cannot even make a 6 mm thick. You cannot even make a very 6 mm thickness of a thickness of wire also you cannot be make it. But in slightly plastic, you can make 6 mm thick supports and supports its own weight. So you can go up to 6 mm thickness of that wire. It can hold. There will not be any breakings. Moderate plastic means you can go up. You can roll about to 4 mm thickness supports its own weight. Here also you can go moderate thickness up to we can go 4 and it holds only its own weight. Very plastic, students, you can go up to 2 mm thickness supports its own weight. So here also its own weight. This is very plastic. These are the conditions: non-plastic, slightly plastic, moderately plastic, and very plastic. This is a condition you can see. Cannot be here non-plastic cannot go up to 4. Here also you cannot be good up to thickness we can go. But here moderate plastic hardly we can go for 4 mm. Up to 4 mm it can hold. Very plastic means if even you can make up to 2 mm thickness. That is what here. See the size, even here also you can see the size was completely different. The length, here you can very weak, but here you can see very long, very big size. Here is a very big size. But here that based on that test only we have made all this. We have come to all these conclusions. Coming to the roots and pores, students. Generally, students, whenever we go to the field description or whenever we go for profile description, generally we can observe some roots, plant roots. Actually they are the evidence. So along with observations, so they will give proper evidence for the soil plant relationship. So the roots generally will give the soil plant layers, especially roots of the perennial plants. So experience the condition in the each horizon along the period of time and respond to the chemical and physical conditions not clearly evident during the profile examinations. Generally we can't see any clear evidence. So in respond and examination, clear evidence we can't be observed while during the profiling. But even though we can go for some examination. What are those? Especially diameter, students. So see, these are root conditions based on the diameter. So pores are the voids. Pores are the voids. Voids mean that space in the soil that are filled with soil solution. Generally, these pores are completely filled soil solution or atmosphere, and conduct through which soil solution, soil atmosphere move to the soil. Generally, those pores, what will happen? Those voids usually filled with soil solution is completely nutrient aspect. So based on that, in that nutrient solution only, we will get the water sample. So you see, you can see roots row zone is there. So generally, student, to record the root or pore quantity, size classes, the exposure phase of the each horizon is examined to determine the diameter of the root or pores exposed. This is what this picture image. So how long this diameter was there? This is what I explained. So based on the diameter of distribution of roots and pores, the following classes has been given here. See, students, if you want to give any very fine class, you have to see that root distribution of that particular how much it should be around 1 millimeter. If you see more than 1 to 2 2 size like this, if you see more size of diameter right root, you can say around fine. If it is a medium condition, you can see 2 to 5 millimeter. If it is a coarse, it is 5 to 10 millimeter. If it is very coarse, more than 10 or more than 10 millimeter, you can see that is a very coarse condition. So based on how much size of root was entered into the profile, we have given different based on the diameter. These are the different classes for the root and pores. This is roots and pores. This one. And coming to the next, after diameter, students, there is another type of class also, units per area. How much units was root was covered? So how much once per 1 centimeter? How many roots are there? For how many fine roots are there? Based on that. So for medium and core structure, unit area was 1 diameter per meter square, one meter square. So based on this, based on the distribution of how much unit area of root pores. Few, common. There are three classes: few, common, many. If we for unit area for 1 centimeter square, if you see only one very few, we can see that is called 1%. It is 1 to 5%. Number of roots common, if you see very less than more than 1 to 5%, that comes under the common. And if you see many, means you have to see more units. So if you see more roots per unit area, that condition is called many. So for roots, the additional classes, there are many things. Very few is there, that is less than 0.2 units are there, and moderately few means it is around 0.2 to 0.1 per unit area. So per unit area, how much root portion was occupied, based on that we have some another classification, that's quality classification: few, common, many. And also there is another very few and moderately few also is may be used for our classification. So this is called based on the roots and pores. We can say we have seen many conditions. So, and well, observing that often usually we noted local conditions there with respect to the structural unit. So we'll get some idea what is the local vegetation, all those conditions. So naturally, students, roots generally what will happen, roots are the conform to the pet faces, or that roots are uniformly distributed. Generally these roots sometimes maybe adhere to the pet faces. So generally what we can see, there's some adheres, and also some customer expression of presence of roots of the horizon, how much size of based on the quantity of the horizon, size, location. And few examples are coarse roots, throughout may find of the roots. That means distribution of root, students. Sometimes in core structure, we can see roots may be completely distributed on the bed faces, or you can see some fine roots in the mat of the top origins. Most in top origins, we can see fine roots. In the in-depth origins, we can see very strong roots. We can see. So based on the pore space continuity, also described. So based on that, we are based on so roots is nothing but how much diameter of root was distributed per unit area, how many roots was distributed. This is what the classification I have given. This is based on diameter, is based on the per unit area how many roots were distributed. So coming to the boundaries, students, horizon boundaries. So how we are going to identify the boundaries of the distinctness and topography conditions. Based on the topography, this is very important, students. Whenever you go to any particular area for surveying, if you want to do any detailed survey, reconnaissance survey, topography is a major important tool for us. Mostly the distinctness of the horizon boundaries. See, students, you can't found a particular this thing. Origins may not be even. In higher topography, in higher area, you can see one type of layers we can find out. In lowland, we can see one type of origins will be there. But in midland, you can see another type of distinctnesses. So based on this, we will go for distinct. So horizon boundary distinctness, there is another type of classification is there. So what are those? Based on the distinctness, student, based on the size, students. So based on the, for example, size of the, so this is the profile. So suppose if we even one profile, you can see mostly this much big is there, one layer. But in when coming to the low layer, the profile, due to the depositions, you can see very lengthy. So based on the size, based on the size, you know, we have based on the change. So for here you can see the change. Again here you can see another layer. The change was very fast here, but here it will come here. So then because the length was very high, the length of each origin is very high, the change was taking some more time. So the based on this, students, based on this, we have gonna there is one classification, distinctness. So how much distinctness? So very abrupt changes. Very abrupt changes means you can see the transition zone. Transition zone means difference in zone. For this, as I said. So very abrupt means this one layer. So within zero point 0.5 centimeters, very very zero point 0.5 centimeters, you can see another characteristics. Another layer was started. That is called the very abrupt. So transition layer was very less than 0.5. If you see an abrupt change, so again 0.5 to from here to within two, after from here to, if you move up to 2 centimeters, again you can see some only up to 2 centimeters we can see one even layer. That is called the abrupt layer. Transition layer we can change, we can see up to 0.5 to 0.6 centimeters. So clear conditions we can say around up to 2 to 5 centimeters. If it's a gradual, if it's very length, here you can see 5 to 15 centimeters you can see. Diffused condition means it is more than 15 centimeters. You can see more than 15 centimeters condition. So it is nothing but change of change of the transition layer. So transition layer is the transition, the changing layer, zero point 0.5 centimeters will be there. Abrupt changes means 0.52 centimeters. You can see the transition layer, you can say 0.225. In the clear conditions, you can see 2 to 5 centimeters, and gradual you can say 5 to 15 centimeters, and diffusion is 5 to more than 15 centimeters we can say, based on the thickness, based on thickness of the transition zones between the horizons we can say. Oh, transitions. Oh, wow. By the way, do you know what is a transition zone, students? I'm saying transition. Any idea? Transitional zone. No idea. No idea. Okay, it is just changing, students. Actually, I'm missing something. Yeah. 1 minute. Yeah. So this is the horizon. Generally, students, transition means think this is the A horizon. This is A. So this is a B. After A, generally what we will see? Sometimes C, mostly we will see B horizon. So while the converting from this A to B, we will see some thin layer. Yeah, this is what I'm missing. Some thin layer will be there. This is called the transition layer from A to B. So this B layer, based on this thickness of this transition, I'm sorry, I missed this explanation. I given some wrong explanation in the previous time. Based on this layer, based on this transition layer, this classification was taking place. Thickness. Sometimes this thickness is 0.25 centimeters. That is called abrupt change. Very very strong changes we can see. But if the change, if it is this transition was around 0.252 centimeters changes, that means you can say abrupt changes with it. If it is around this transition layer was 2 to 5 centimeters, you can there is a clear changes will be there. If it is 5 to 15 centimeters, there will be gradual changes. If it is more than this transition layer is more than 15 centimeters, that is called the diffused changes. That is called the distinctness of the diffused transition changes. Is it got it, students? Is it understood for everyone? Is it understood? Are you following me? Okay, I hope no answer. Anyhow, you're not giving answer. I'm proceeding to next slide. So horizon boundaries. Mostly students, you can't found the origins completely. Say for example, as I said in the, you can't found all boundaries or all horizons in one particular area. Say for example, in highland you can see in very highland you can see one type of layers. Mostly most of the layers will be moved up. Generally there will be very length, but in lowland, midland you can see one type of layers. In lowland you can see due to the heavy depositions you can see many lands, many horizons we can see. So this difference, so there is no continuity. So horizons will not have any continuity up to this horizon up to here only. But here you can see, but here you can see some additional horizons also. So some horizons are discontinued. So there is no continuous horizons may not be there. Generally in uplands you can't expect any organic layer because everything was leached out. But here you can expect one type of horizon. O horizon may be present because of lowland. Some vegetation is prevailing here. So this discontinuation of these horizons, based on this discontinuity, we can see one type of classification is there. So if the horizon topography was smooth, planar boundary with few regularity. If there is on top, if the topography condition was like this, planar boundary, the boundary was very plain, and there you can see only very few irregularities. You can't see much difference, very few irregularities. That is called, that comes under smooth.
Sir,
That horizon topography is smooth. Yes.
sir, screen is problem, sir.
Screen is not visible.
Yes, sir.
Oh,
Half of visible.
now it is okay.
Okay, sir.
Yeah. Here we are missing abrupt. Yeah, smooth. So smooth, students, smooth means planar boundary we can see, and in the wavy condition means boundary undulating. Topography is very wavy. Wavy means up and down is there. What we can see, boundary undulating with vertical distance less than lateral distance. So vertical distance will be more. Generally, what will happen is where these wavy conditions, the condition was like this, topography was like this. You can see the vertical distance is very more when compared to when compared to flat land. Here you can see vertical distance is more, right? This was condition, wavy condition. Irregularity, so there is no any proper, there is some irregular, sometimes you can see plane, sometimes you can see depth, sometimes you can see very high. This type of irregular topography is there. Means what will happen, boundary undulating with lateral distance. So generally what will happen, this boundary, this here is a plane, you can see more lateral distance will be there. Here also you can see depth will be there. Here also you can see some other different kind of profile conditions are there. So like this, some irregular vertical distance will be very high. Broken conditions, horizontal laterally discontinuous. Broken condition means like this, students. In here one profile will be there, and here in middle you can see some water body will be there. Here you can see some plain, and again you can see some lowland, again you can see upland. So like this zigzag fashion of zigzag fashion of distribution means that is called the broken. You can't find any single layer of horizon properly in all profiles. So that condition is called broken condition. Horizon is literally discontinuous, so you can't see any continuation. If you see one horizon or one area, you can't see that horizon in another area. So this is a problem. So this is called smooth based on topographic conditions, students. Smooth, wavy, irregular. Smooth means generally planar boundaries, all of plane conditions. You can see all type of boundaries. We can see some with some few irregularities, but in wavy conditions, due to that wavy, this up and low conditions, what will happen? The vertical distance of the profile is very high than the lateral distance. But in irregular conditions, paka opposite. So the vertical distance was less when compared to the lateral distance. The profile lateral conditions was very different. In broken conditions, origin was completely discontinued. There is no any continuation. But this to evaluate this type of profile is very difficult, students. So distinction of the profile recorded for the lower boundary of the each horizon. Generally, we will record the topographic conditions. Generally, whenever you visit for any profiling or any conditions, very first we want to see what is the nature of the topography of that particular area. Based on that, we will go for this classification. So whenever you dig a profile and all those things, then you have to give in a description of your analysis. So the topographic condition was smooth if it is very plain conditions, or if you see any undulating or any broken or discontinuity, very high discontinuity, then you should say the topography was completely broken. I can't find any similar boundaries or similar horizons in any profile. Like this, we have to give one type of classification and add additional features also, students. To this after concluding all these profiling conditions based on the transition layers, based on the stickiness, based on your consistency, shear resistance, all those things, you have to go for additional conditions. The pet coatings, how the mottles are distributed. Coatings means nothing but mottles. How the mottles were distributed, concretions are the concrete, the adherations, how as the concretions are there, how the pH condition is there, what is the condition of salinity and of the presence of carbonates are there. You have to go for all these conditions. So so these are all the field observation, students. In laboratory, what we will do, we will do the analysis. We will see the very peculiar. We will go for other nutrient analysis like NPK, magnesium, etc. Or if there is any heavy metal toxicity, we'll go for all those things. So based on that data also is completely added to our particular surveying project, the particular pedagogical evidence. We will add all those things. Then we'll go for further many analysis conditions. These are some additional features we add to our profile description. So up to now, here in coming class we will discuss about the horizons. Horizons means generally we have already learnt what is a epipedon, what is a pedon, etc., etc. So based on that, there are some materials will be added. What is a spodic material, what is a linetic material. So we have many things we will learn in the next class, students. So with this, thank you very much.